Assalamualaikum and a very good morning. So here we are in the second chapter of instrumental analysis. We are going to learn about the second spectroscopy based method, which is fluorescence spectrometry. Okay, so this is again a molecular spectroscopy because it can be used to analyze molecules. Okay, molecules because fluorescence spectrometry is like a derivative of UV visible spectroscopy. Still, it can also analyze organic compound, okay, molecular state. It's not atomic yet. Okay, so however, we have to understand what is the difference between fluorescence and UV vis spectrometry. Okay, even though it's a derivative, it is a bit different in terms of the emission of light. Okay, the emission of light. So for this topic, I'm going to introduce to you what is luminescent, the origin of fluorescence, what makes molecules fluoresce. Okay, there must be something inside the molecule that makes it fluoresce. Okay, what are the instrument parts and how to see spectrum, how to read spectrum, and then we will go into a little bit in phosphorescence. So phosphorescent and fluorescent, the difference is at the beginning of the prefix over here, there must be some kind of difference that make it unique to each other, and of course the application. So what is luminescent? Luminescent, if you hear from everyday conversation, you say the sky is illuminating, the star luminous, and so on. So what exactly is luminescent? So it is happening because of the emission of light. How did the light emit? Okay, after the compound return to the electronic ground state. Okay, so this is the part that it is different from UV visible, whereby in UV visible spectroscopy, the radiation is absorbed. Okay, and then we just analyze how much it has been absorbed. Okay, based on the transmittance left after that. Nothing after that. Okay, we didn't analyze anything after that. Okay, whereas in fluorescence, we are analyzing the emission after absorption from ground state to excited state, and when that energy want to reduce back to ground state, it emits something. So based on Jablonski diagram, okay, there is a certain level, whether it's a single state or triplet state. All this depends on the molecules that been bombarded with the radiation. Okay, so that is a luminescent in general. Okay, whereby it will lose its energy as photon. So this kind of energy as photon, that is what we, if let's say is in general application, that's what we see as a fluorescing color, and is sometimes is really intense. We know immediately this is fluorescence. Okay, while in instrumentation, the instrument depending on the optics being used, it will be collecting those energy and give us signal. Okay, so luminescence can be caused by several variation of and also reason. Okay, most of them are chemical changes. Okay, can also be in the form of biochemical change, what we call as bioluminescent. Okay, then we have electrical energy and also we have reaction in crystal as well as stimulation in atomic system. Let us see what are the examples of luminescence. Okay, the one that is covered in this topic is under photoluminescence, whereby we can see the emitted radiation, but because it's in instrument, we cannot see as in naked eye, but the instrument will see that photoluminescence. It is covering fluorescent as well as phosphorescent. So fluorescent is this photo image, while phosphorescent is something that we usually see. Okay, this is glow in the dark toy. Glow in the dark, we can see because there is the gap in terms of energy release. As compared to fluorescent, the energy release duration is longer in phosphorescent. Okay, and then we have chemiluminescent. The luminescence is based on the chemical reaction between A and B. What is A, what is B? Okay, have a look at this photo. Okay, this is commonly found in any crime scene investigation drama, right? Okay, whereby we suspect that there is blood, and then we spray with some chemical, for example, luminol. Okay, and then this luminol is containing the reagent that can chemiluminesce the blood. The blood contain iron, for example, which is the catalyst for the luminol to luminesce the light. Okay, you can have a look in the book or Google on the chemiluminescence based on luminol reaction with iron inside blood. Okay, and then we have radioluminescence, but it's not that popular nowadays. Electroluminescence and bioluminescence. So bioluminescence is based on the biology activity within a species. What kind of species? This photo shows you the marine species, specifically dinoflagellates. I happen to see this kind of phenomena back in 2012, if I remember it correctly, when I was doing a PhD in Australia. We have this dinoflagellate bioluminescence every year, and we take the opportunity to see with our own eye how they actually bioluminesce, and it's almost the same like how fluorescence and the glow in the dark intensity of light. So it's really nice. If let's say after this you go to Australia, New Zealand, or some Irish sea, you can see this. Okay, so type of luminescence. So this is a general definition of fluorescence. It happened, sorry, this is not definition, is only the like how that happened and how quick it is happening. It is happened quickly after initial photon absorption between microsecond to picosecond lifetime, which is very fast as compared to phosphorescent. So in Jablonski, why this happened? In Jablonski diagram, you can see that the wavelength starts from here, 2, 3, and then this is the energy, right? Energy Jablonski. I don't know why this happened. Phosphorescent, okay, is somewhere around here. Phosphorescent, while this is fluorescent. Okay, to show the difference in terms of time, the duration, the luminescence happen. Phosphorescent is so slow, it can go up to minutes. That's why glow in the dark we can see within minutes. It's not as fast as fluorescent. Chemical luminescence, the excitation arises from chemical reaction. We can see the luminescence as long as the catalyst, catalyst in blood is inside blood and the luminol is there. Okay. Then we have a radioluminescent produced by bombardment of energy, such as X-ray radioactive wave or alpha particle. I forgot to mention the source of radiation for fluorescence and phosphorescence is still UV. Kenapa macam ni ya? Is still UV radiation. That's why I said just now, it is the derivative, like it's the integral part of UV-based spectrophotometry because it's still using UV radiation. Okay, electroluminescent is a conversion of electrical energy into light. Bioluminescent is produced with by a chemical reaction within organism. Tadi organism dinoflagellate. Sorry. Okay.